Good day, we're from the Group 6 of Brother Flavius. Today we'll be presenting our investigatory project titled A Comparative Study Between Using Red Wigglers and Common Earthworms in Vermiponics to Determine the Effectiveness on Lettuce Growth. That's all, and let's get started. Let's start with the background of the study. The ongoing pandemic has greatly affected the accessibility of food throughout the globe. People are stuck on their own homes and are unable to acquire food. However, with the help of vermiponics, they could grow their own crops in their homes without the risk of going outside. Vermiponics is the combination of vermiculture and hydroponics. The concept of this alternative urban gardening method is very similar to aquaponics, except its nutrient source is coming from the worm waste rather than the fish waste. It is also more water efficient than hydroponics since it uses 90% less water than the traditional gardening method. Not to mention that hydroponic setups are prone to algae growth, as it has the perfect conditions for growing algae, which in turn attracts fungus gnats that damages the roots of the plants. Furthermore, vermiponic setups also helps in reducing household waste by converting food scraps into valuable nutrients on which the plant could use. Despite all these benefits, this urban gardening method is unknown to many people. The research study could help give acknowledgement to vermiponic setups, which could help many people.
Good day. I'll be discussing the statement of the problem of our research. Our research study has come up with 3 objectives, and these are: Objective 1. Which of the two worm species, common earthworm and red wiggler, is much more effective as a nutrient source in vermiponics for the growth of lettuce in terms of A. Growth of the lettuce, B. Weight of the lettuce, and C. The color, texture, and development of the leaves. Objective 2. How effective is the common earthworm as a nutrient source in vermiponics to support lettuce growth? And lastly, Objective 3, how effective is a red wiggler as a nutrient source in vermiponics to support lettuce growth?
Good day. I'm going to discuss the significance of our study. The aim of our research is to provide our citizens a clearer point of view on vermiponics, on which they could use to grow their own crops at their very homes without the risk of going outside. Our research also aims to help reduce household waste by converting it into nutrients on which the plant can use. Future researchers could also use our research study to improve their knowledge on sustaining plant growth with the use of vermiponics.
Good day, everyone. I'll be explaining the scope and limitations of our study. Our research study shall only focus on the effects observed between the common earthworms and the red wigglers to the plant growth of vermiponics. Furthermore, hazardous organisms such as fungi, parasites, or pests that may be met while attempting the research will be excluded by the researchers.
Good day. I'm going to be discussing the materials and methods for our research. Our conceptual framework will be consisting of gathering of materials, construction of the vermiponic setup, planting of the lettuce seed, maintaining of the worm bin, transplanting of lettuce, and lastly, observation and gathering of data. The materials that we'll be needing for the vermiponic setup are submersible pumps, a timer, air pumps, air stone, gardening tray, 50 liters of storage boxes, 4 kg of pebbles, 4 kg of peat moss, newspaper, netted pots, food scraps, soil, PVC pipes, and 2 kg of expandable clay pebbles. Here are the blueprints from the vermiponic setup. It will require a gardening tray, a worm bin, and a water reservoir. For the gardening tray, the first step is to make a hole with a diameter of 3.5 cm at the bottom. Make sure the hole is 40 cm away from the right and 6.5 cm away from the left. It should be also 15.3 cm away from the side of the walls of the gardening tray. After making the hole, place the netted pot into it to keep the expandable clay pebbles from falling. Angelo Ramos will continue our report.
Good day! I'll be continuing the discussion. For the worm bin, drill 39 holes at the front and the back of the container and make sure that it is 4.3 cm apart. The holes should be 20 cm above the container to make sure that the air is circulating in the worm bin. For the side of the container, drill 9 holes and make sure that it is 12.8 cm apart from the side and 4.3 cm apart from above. Always make sure that it is 20 cm above the container. For the bottom of the container, drill 20 holes and it should be 9.6 cm away from the side and 13.8 cm away from above. For the water reservoir, leave the container as it is and place it at the bottom of the worm bin to catch the water dripping. Set up the submersible pump and air stone and make sure that the water is circulating the vermiponic system. Here's the concept diagram for the vermiponic setup. It has the labels for the materials that the research is going to use. Here's also the 3D model for the vermiponic system. For the plants in the gardening tray, the lettuce plants will be planted 10 centimeters apart from each other and 12 centimeters away from the sides of the gardening tray.
Good day everyone! I'll be discussing the projected cost analysis of our research. Most of the materials will be bought through online shopping. For the vermiponics setup, we're going to be needing 2,000 grams of expanded clay pebbles, which cost 600 pesos, 4 kilograms of peat moss, which cost 700 pesos, 4 kilograms of black pebbles, which cost 160 pesos, 2 seed growing trays, which cost 360 pesos, 2 programmable timers, which cost 560 pesos, 1 pack of lettuce seeds cost 60 pesos, 2 submersible pump, which cost 1,120 pesos, 4 storage boxes cost 1,100 pesos, air stones cost 76 pesos, 4 L pipes, which cost 60 pesos, PVC pipes cost 96 pesos, 2 air pumps cost 300 pesos, common earthworms cost 200 pesos, and lastly, red wigglers, which cost 250 pesos. The total amount of the expenses are 5,642 and will be divided into 806 pesos for each member. That's all, and thank you.